talked about the regulator, which is down here. First, we'll start off with the distribution of the gas. Like when it comes in, what does the regulator do as far as going out the regulator? One of the things we said is the regulator maintains gas pressure inside the stove the whole time. So whatever gas pressure is coming from the tank coming in, could be high or low, the output is always going to stay the same because of the regulator. The regulator has this line coming in, and we have two lines coming out here. This one is going to the oven safety valve. We'll talk about the oven part another time. Right now we're going to talk about the surface cooktop and how that works. Now this line here comes out the regulator and goes to something called a manifold, and I'll show you that in a minute. One thing we didn't talk about the regulator, the piece is missing from right down here on the bottom of the regulator. That's a little like shutoff. I've had customers go behind it with a broom or a mop and try to clean and got caught on that shutoff. And that shutoff will shut off the gas to the oven. So if you were to push up on the lever here, which is missing, this little piece comes out right here, like this. You can see I'm moving it. That will shut off the gas to the oven. Okay? We didn't talk about that when we were talking about the regulator. So this line goes right into the oven. This one goes up to the top, and then we'll turn it around, take a look at the front. Get this out of here 1 second. And I've already removed all the screws for this control panel, so you guys can see everything here. Alright. So that gas coming in from the regulators coming in through this line into this rectangular tube here called a manifold. The manifold supplies gas to all the burners on the top of the stove. In some stoves, instead of having a temperature control that's electric, they have a gas oven control, like a thermostat. And it would be mounted on the manifold, and it could control the gas going down into the oven. So instead of coming right off the regulator into the oven, the gas would come up to the manifold, and then the thermostat, if it was a gas thermostat, would go back down. In this case, it's electric thermostat. So we talked about setting the regulator for LP or for natural gas. When you buy most appliances, dryers, stoves, they usually come from the factory set up for natural gas. And there's conversions that need to be done. One is the orifice. This particular orifice is not adjustable. Go ahead and here's a wrench. This is called an orifice. The word orifice just means opening, okay? And this comes off of this part right here, which is your gas valve. Works the same way like a hose, a garden hose. You have a valve that you control how much water comes out to the hose. Well, the manifold brings gas into this valve, and then when you turn the valve, you're controlling the gas coming out. You can turn the valve one way or another to increase the flame size. On this one, the orifice is not adjustable. You actually have to replace it from natural to LP. Now this one's already been converted for LP, so I can't really show you the adjustment. But on some of these, and when we do the oven, I'll show you the adjustment on the oven. The orifice is an adjustable orifice. We can turn it one way or the other for the type of gas that we're using. So depending on the type of stove, you have replaceable orifices or you have adjustable orifices. So how does this work? Gas comes into the manifold, comes to our surface valve here. Let me just put this back on. And that orifice shoots the gas right down the center of this burner tube. Okay, and I'll show it to you on the side here. Here we have an opening which is called an air shutter. So if I rotate this air shutter, I can close it or open it back up to control how much air comes in. So natural gas, we said, was 3 to 5 inches of water column pressure. It's very low pressure. LP, which is what we're using, propane, that's about 7 to 11 inches. And because this is a barbecue tank or tank with a barbecue regulator on it, it actually may run as high as 14 inches water column pressure. So when gas is shot down the center of this tube here, it goes right down the middle. It's very important that it is lined up perfectly down the middle. Anybody have any idea why it's important when the burner sits on top of the orifice like this, why it needs to be like right down the middle?
Because if it doesn't, it hits the wall and then your igniter won't light the gas.
Well, it'll probably light, but here's two things. When it comes down here, right here, it's pinched off. Can you guys see how it's like pinched off here, like smaller than the rest of the tube? You see how it's all pinched off right here?
Yeah.
It's pinched off at this point because it's called a venturi. And the idea, as the gas comes in here, it pulls in air, because in order to burn, gas alone doesn't burn very well. It needs oxygen to create that burn. So when it shoots down the center, it's actually pulling in oxygen through these two openings here, and it's mixing that fuel and oxygen inside the venturi before it comes out to the burner. All right? Now, if it doesn't shoot straight down, it's not going to pull in the air properly, so we won't have a proper flame. But the other thing that could be wrong with it is that if it shoots off at an angle, it might shoot gas out instead of pulling air in. So if your burner and your valve are a little bit off at an angle, they're not perfectly straight, we're not going to get a good flame. So that's important. And these valves here can be turned just a little bit and installed improperly. So once the gas comes up through this burner here, we have the main burner head here, and when the flame comes out here, that mixes with another amount of air. So this is called primary air, and this is called secondary air. Okay? Now, there's little tiny holes there. Can you see the little tiny holes on the side of the burner there? See those little holes on the side of the burner? Can you see those holes, Carl?
Yes.
Right down there on the side.
Yes.
Okay, can you guys see those little tiny holes there? Okay, so while the gas is coming out the burner, a little bit of gas is shooting out those holes, running through this called a flash tube. Okay, so it shoots gas all the way out to here where our electrode is for our ignition of gas. Lights the flame, and the flame runs back through the flash tube and runs up the burner. What do you guys think can happen with these holes here over a period of time?
You get clogged up.
They get clogged up. Clogged up with what?
How
So,
you call that? Soot, carbon.
Not soot, actually grease. Like when they're cooking.
Oil.
When they have the pan over top of it, the grease is not going to get there because the pan's so big and the burner's so small. But if I'm cooking on the front one, grease can splatter onto the back one, or vice versa. So a lot of people may call you out and say, oh, this one burner's not lighting. Obviously, the first thing you want to do is see if you see this little electric spark here, and we'll talk about that in a minute. But then you want to make sure these holes are clean. I've seen people take these off and clean them, and they throw them in the sink, and they submerge them in water and try to clean them. Well, these look like aluminum, but they're not pure aluminum, and actually inside of them they start to corrode, and if you get like flaking of the metal inside, you're going to cause problems with the burner. Okay, So let's go ahead and light this, and we'll talk about the lighting process. Is the gas on?
No, so
Okay, I'll turn it on. I got it, thank you. So I'm plugging in. Turn on the gas. I'm gonna go ahead and stick with a little front one. Now, on the front of this, we have a little electric switch. Okay, it's a surface igniter switch, and they're all wired together, all four of them. Which is all send power to something called a spark module. We'll look at that in a minute, it's in the back. That spark module, when it gets power, it's 120 volts, causes the spark to come off of here. Now when you light this front burner, or this one, both of them always spark. On most of them, the spark igniter does not differentiate from the front rear, or the front right, or the left rear, or whatever burner it's on. Most of them, when you send power to it, they all light at the same time. Okay, so when you turn this dial, you're doing two things. You're opening up the gas valve so it can light up the burner, but you're also closing the switch here to tell the module spark. And on your knob, there's a high and a light position on there. It says LITE. That's to light the burner. So when you turn it, you don't just turn it a little bit, you turn it till it starts sparking. Now normally, we have a line here on our display, so when we rotate it till we see the word light line up with that line. That's how we know when to light the burner. So if I put the knob on there, I'm sending gas to the burner immediately, and I'm going to turn it till sparks. I want you guys to see, you're going to see sparks coming off of here like a little lightning bolt. It happened pretty quick, didn't it? All right, now it's a little hard to see this flame. Flame's about 1.5 inches to 2 inches long with very little yellow flame. That's what you want to see. You want to see an even burning flame, and you want to see very little yellow. Customer calls you out and says, I'm getting all this black soot on the bottom of my pots. What does that mean?
You have an improper flame.
Okay, a little bit more though to the improper flame.
Not enough air or not enough gas.
Not enough air or not enough gas. Which one is it? It's one.
Not enough gas.
Not enough air.
Not enough air. When you're lighting torches,
Yeah.
you give it too much gas and not enough oxygen, you get that big yellow flame. When you add the oxygen, it starts to turn blue. Watch what happens. I'm just going to take my fingers and cover up the primary air holes, restricting the airflow coming into that burner. Okay? Now, when I go like this and I block the holes,
Yeah.
look at that flame. When I open up one, I still have some yellowing on the tips. You see that? When I open up the other, I lose a lot of my yellowing. So when you see too much yellow, you're not getting enough oxygen for the flame. Okay? If you got a real big flame, that's in yellow, that's oxygen. What happens if I have very little gas but too much oxygen? The flame won't light, or it'll pop and go out, or your flame will be very, very little. Now, I don't have a pocket screwdriver, but inside of this dial, there's an adjustment screw. Anybody have a pocket screwdriver? Like a little pocket one? Little flat one? Now, there is an adjustment setting for the low flame of the burner, and it's inside the shaft of this valve. So when we light the burner, and we turn it to stop sparking once it lights up. A flat one, yes. one, let's see if that one fits. It might be a little too big. Let's see.
It's too big.
It has to actually be smaller than that one. This one won't fit.
You could.
Let me see if this one will fit. Joe, here. I think this one will work. So inside of here, there's usually, yeah, this one will get in here. I can't get to the screw. This one may not have the adjustment, but you have to look at each different burner. Inside of them, they call it the simmer adjustment. So when we turn the flame down to a lower flame, really low, we should be able to go in here and adjust the low flame, the lowest setting. So when I turn it, it doesn't totally shut off. So you have the high flame, and then you have the low flame. And a lot of the more high-end ones have a screw inside the valve here where we can adjust what they call the simmer adjustment screw. Okay? So let's see here. Let's try lighting another burner. Now that is a good flame. That's what we want to see. It's a little hard to see. You probably have to turn off the lights to get a good view of it. But that flame is about not that long, 1.5 inches, 1.75 inches. That's about perfect for cooking. All right. Now we got higher end units with bigger burners that cook on bigger pans and everything else. But that's what I want to do. So the spark ignition, I'm going to go ahead and unplug this here. We got these screws back here. Let's take it off. These aren't the regular screws for this panel, but so this here is the spark module. This is what sends the spark to the burner. We have 2 wires at the bottom of it, this red and this white. These are the ones that get power from that switch on the surface valve. They call it the surface igniter switch. These 2 are the spark igniters themselves. They have no resistance. They're just almost like a piece of wire from one end to the other. If you wanted to test them, I'll pull one of the wires off here and show you. So I pull this wire off. Let's take our meter. And if I wanted to test it, I'd stick 1 meter lead in here. And I just touch the top of the other one, see if I get a reading, and I get a reading. Okay, so that wire that I just took off is that igniter on the top of the stove. The electrode on this is ceramic, and I'm going to go ahead and take this off to show it to you. This little bit here is usually made of ceramic. Because the spark comes off the tip of this, it has to jump to ground. So the bracket that's holding this down completes the circuit for that spark. If this is too far away, the spark has no place to jump. Now on the more high-end units, each burner would have its own electrode. And that electrode would be right there by the burner like that. Sometimes they have a hard time for them not lighting. Either the burner hole is clogged with grease, or it's not lined up right with the hole when the gas comes out. If the hole's just a little bit off away from the electrode, it's not going to light. Yes?
Wouldn't that bracket change within so much use? In other words, wouldn't it warp a little bit further back, or does it always stay?
No, because this bracket is located here away from the flame. The one on the burner, this is just located like right there. There's no like bracket like this, because the spark jumps to this bracket because of where it's located on the burner. Those burners don't have that flash tube. They spark right on the burner themselves. Okay? So if you're seeing a spark and it's not lighting, the problem is the gas is not reaching that spark. Now, what would happen? I have 4 burners here. Let's just say this one and this one and this one, when I turn them on, they all spark. But when I turn this one on, I don't hear any sparking at all. What do you think the problem is? Yes.
Bad spark mode.
Bad spark module in the back?
Yeah.
What you were talking about, that goes into all of the different, I forget the word that you used, but it goes into each and every one of them. It wouldn't
Yes,
flow
but-
through that one.
Yeah, but let's go back to the module again. Let me take this one off here. I'm going to take all the wires off. Spark module has 2 wires coming in, power and neutral. These 2 go out to those 2 electrodes there. Okay? Both of those electrodes are sparking when I turn on this one, and this one. If that's the case, is the spark module bad? It can't be, because this spark module only sends power to the 2 electrodes. And if it works on one of them, the module's good. All we have to do is put 110 volts there, we get sparking. So the problem is the switch itself, the surface igniter switch, is not telling the module to come on. Even though they're all wired in parallel, the contact in that switch could be bad. Okay? So if you have 3 are lighting and the other one's not sparking, it's most likely that switch. Now what if none of them work? I turn all of them on, I can light the burner with a match, but it's not lighting, it's not sparking. Probably the module. It could be power too, right? It could be something there. So what we want to do is we want to go to these 2 wires right here, the power, line 1 and neutral. Let's turn it back around. That's this red and black wire coming in, or red and white wire, I'm sorry. Put the white wire here, put the red wire there. If I don't get no spark coming to either one, I want to know if I'm getting power here. How do I do that? How do I make that test? I just said we're checking for what?
120.
Power, right? Checking for voltage, okay? So I put my voltmeter here, but what do I got to do to check voltage here? I have to
Turn on.
energize one of these. I have to close this switch to send power there. Now you guys got to be very careful, because it's not very high amperage, but it's high voltage. So feel like a bee sting if you get shocked by one of them. Okay? It'll make you jump. It's electricity. So be very careful. But when you check power here, if I have power here and neither one of them are sparking, most likely what? The module's bad. If I don't have power, I have to check elsewhere. Now let's go back to this electrode. Some of them, these ceramic, may be about 2 or 3 inches long. I've seen the ceramic crack. And the bracket that's holding it, you don't see it here. You say, hey, the burners on the right are burning, but lighting, but the ones on the left aren't lighting. I've seen the ceramic here crack, so instead of the spark coming off the end, the spark is jumping underneath somewhere and the burner won't light. I've actually seen this wire, you know, people work on it or from the factory, and they pinch the wire with the top and it cuts into the insulation, so the spark is jumping here. Why would it jump here and not off the end?
Because it's not centered, it's not in place.
Well, this here is insulated, but if it's closer to ground than this is to the tip here, let's go back to the tip here. This tip here is probably a 1/4 inch distance.
Yeah.
If I'm a 1/4 inch or less at the wire, the air actually is resistance for that spark. It's gonna go to whatever the closest is to hit metal. Okay? So if it's not working, what you do, let's just say one side's not working, the other side's working. You're like, okay, well, how do I know if the electrode's bad or my module's bad? Where did I set that module? Oh, here. If one side works, which are these two wires here, one side works and the other side doesn't, just switch the wires. Remember, they both spark at the same time. If you switch this one that was here, move it over there and vice versa, and this one still don't work, no matter where you put it, my electrode's bad, I need an electrode. If I move it from here to here and it's working, but it don't work over here, it's my module. So there's not a lot you need to test when you test it. You check power to it, and once you check power to it, you see if you get spark coming off the end. If neither one are sparking and you got power here, most likely this is bad. If one sparks and the other one not, switch them. And if the one that didn't work still isn't working, then you replace this. It's just a wire running up to here. Pull it out, put a new one in. Yes, sir.
On different ranges, is different size electrode, right?
Well, no, these two
different
are
ranges.
almost identical, the same part number.
Yeah, but like certain ranges got longer electrodes.
Yeah, on the more high-end ones, they are different types. Like I said, that some of them, the ceramic could be at least 2 inches or 3 inches long.
Yeah.
Okay, pause it for a second. Start the camera. This is called a slack tube manometer. Now this is a ruler running down the middle of this, and the ruler goes up and it goes down in measurement. So when we read it, we read from the 0 up and the down, and we add those two numbers together. First thing we did is we added water to it, and the water's got to be even, and if you see here, they're not that even. Now, I have too much water in there right now. I need it to be
Down there.
at the 0. So when you're filling this thing, it's very, very difficult to get it exactly right. So you have to play with it a little bit. And I'm just gonna drain out a little bit of water into a container here. And now our water level's real low. You see that?
Mhm.
So pause it for a second. All right, so first of all, took us a minute to get the water even close to 0. One thing nice about this manometer is that this ruler, I can slide it up or down to get it lined up to 0. There's our water lines are right there, and it was off, but I can slide it up and down and get it to 0. So you don't have to worry about getting it right on. But this tube is so small, it takes very little water to go up in. So don't add a lot of water, because it'll jump up real high, and then you're draining it out, then you're adding it, and you're draining it out like we did. And once you get the water to about 0 here, what we want to do is we want to remove one of the burners from the stove. And let me get the hose here. When we slide the hose onto the gas valve to read gas pressure, we choose only one of those valves. As soon as I slide the hose on, it's going to push the air in this hose. It's going to actually make a slight pressure reading just by sliding on the valve. When I slide on the valve, any air in this hose is going to be put on there. So watch the water as I attach it. And what you do is I removed one burner and I slide this right over the orifice where the burner would sit. So it goes right over where this goes over the valve. You can see here, I slid it right over the surface valve orifice. I could have chosen any one of those valves because the gas pressure is the same. And why would we even measure the pressure? I mean, what's important about that?
Measuring the pressure will tell you if you have what type of gas you have coming in, and it'll also tell you if the regulator is bad.
Well, not necessarily what type of gas. Yeah, you would know if you have this gas or that gas because of the pressure readings that you're getting. But you don't want, not that you don't, but you want to know the pressure, because if I'm using LP gas, I want to know if I'm within range. Because if the customer is complaining that their burners are not lighting or burning properly, then you need to know, okay, is there something wrong with my stove, or am I just having a gas pressure problem? Okay? And that could be a fault of the regulator or fault of the gas line coming in. So let me just connect the wires here to the spark module. And reconnect my electrodes. So we're going to have to fire this back up. Now here's an important thing. If you look at the spark module, there's a metal ring here. The module needs to be grounded properly too in order to work. So if I have it just hanging like this, it may not light the burner. Okay? So let me reconnect this one wire that came off again. These not coming on. And I gotta put a screw back in there. These screws are stripped out, so they're not going to ground properly. I'm just gonna let it sit like that. Okay. So we're going to take two pressure readings. All right? Does anybody have an idea why I'm going to take two different pressure readings?
You see the
Oh, it's the
gas
same
level?
burner?
The gas level?
The what?
Gas level?
The gas level? Yes and no. One, we want to know the gas pressure coming in. All right? When I open up this valve, whatever pressure's in that pipe is going to go into this hose. It's going to push the water on one side down, the water on one side up. We said it should be between 7 and 11 inches. So, you got a question?
No.
Oh, okay. So I'm going to go ahead and just turn this one here. I don't need it to light because I'm not trying to light the burner. And by doing that, I'm letting the gas go into the valve. Is it reading?
No.
No. Might have something caught inside of our valve. Pause it for a second, Carl. Alright, so I'm going to turn the gas on. Yeah, the unit's still not working. Our slack tube don't seem to be working properly. So we got an issue with this unit. It's the meter though. So let's do this.
Try a different burner.
What?
Try a different burner.
No, we're gonna go to our digital gauge. Where's the digital gauge? Still recording? Okay. So this one here, we gotta click on scale. This is millibars. Okay, that's PSI. And that's inches WG. So we're going to go inches WG, and I'm going to go ahead and connect this to the top of this meter. And I connect it. Remember I told you that as soon as you connect the hose, it's going to put pressure on the meter. Meter's going to read it. So we have a 0 button, and once we connect it, it's supposed to 0 out. And it doesn't seem to be zeroing out properly. So what we want to do and this has a magnet on it, is we turn this on.
It's zeroed out.
Oh, now it's zeroed out. But why don't we get into reading?
Did it zero out with the gas line on?
Gas is on.
You gotta read it now. With
That's hilarious.
In the vacuum.
Yeah, but that's not even one. So let's hit 0. Let's stick the hose on there. And we're gonna go and turn the gas on. There we go. What are we reading?
11.89. Yeah.
11. So is that between 7 to 11 inches?
Mm-hmm.
So we have proper gas. But remember I said we need to take 2 readings. I don't know what the water manometer didn't work, but we'll mess with the water one later. That one is static, okay? It means it's just the pressure without the gas flowing. You could have that same kind of problem in an electrical circuit. You could go to an electrical outlet, put your voltmeter there, and it says you got 120 volts. But if you have something else plugged into the other outlet and you turn it on, the voltage could drop to almost 0. So we need to get a pressure reading when it's off, and then we need to make a pressure reading when another burner's running. So when the gas is flowing through the stove, we need to see, it might drop a little, and then what's going to happen? The regulator is going to bring it back up. So watch the meter as I go to light another one. Let me plug it in. And I'll light this front one here. And the burner lights. Did we see anything happen to this one?
To 64.
Okay, but that's 0.64. That's not even.
It dropped by 0.2.
Yeah, so it dropped just a little bit. When I turn it off, what happens?
Goes back
Goes
up.
back up.
Go
It goes
back.
back up, but just minor.
Mm-hmm.
It's
Okay.
so minuscule you wouldn't really be bothered by it.
And this is what a regulator is supposed to do. We really don't want to see a big change. If we saw a big change when we turn on more burners, they're all going to get smaller. Or bigger when we turn them off. We don't want that to happen. So when we're checking a regulator, we're checking pressure. This is the pressure we want to test when another burner, even if another burner is working. Let me go ahead and light the back one now. The
Went
back
down by
one.
another 0.2.
But not much.
That's it. It's just going down by 0.2
Very
for a
minimal.
burner.
So I got these 2 burners working, but my regulator's maintaining my pressure so that all of them are functioning properly. Okay?
Where's the regulator
Right down there in the back where the gas is connected. The black hose is going right to it. So, the surface unit's not difficult to troubleshoot. One, we want to try to light it with a lighter. It's best that you have one of those barbecue lighters or
Yeah,
candlestick lighters, so it's got the real long piece on the end so that your hand is not right there in the flame. If it does not light within 2 or 3 seconds of you turning the gas on, stop, because gas could be leaking out and causing a problem. Now there is another test that we could make while we have the manometer connected. Does anybody have any other idea what other kind of test we could make?
Alright, Tesla number is connected.
Think of refrigeration. And I will say nitrogen. What do we do with nitrogen, and how do we test a refrigerator with nitrogen? What do we do?
Just
For leaks,
How do we test for leaks with nitrogen?
we flow nitrogen through the system. To,
We don't flow it, we fill it up to what?
So 100.
To 100 psi,
Mhm.
and we shut the tank off, and we watch our gauge. Our gauge should say 100. If it's leaking, what's going to happen?
It's dropping.
Goes down.
It's dropping. So as long as I have this tank on, if I have a small leak, it's going to say the pressure because the tank is constantly keeping it at that pressure. But if I had a gas stove, customer called me out and said, you know, my gas stove's leaking gas. And you're like, you put soap over everything, you don't see no bubbles. No, but I smell gas, So what you do is you connect your manometer up, you turn this burner on like we have it, so it gives a reading. You go to the gas supply, usually a shutoff right behind the stove, and you turn off the gas. If it stays at that pressure and doesn't start dropping, my stove doesn't have a leak. But there are some exceptions. This is a spark ignition, which means it sends a spark. The oven is what we call a glow ignition on this unit. It has an electric igniter to ignite the burners. The thing is though, is if you have a gas stove that has a pilot ignition and you turn the gas off, the pilots will leak gas and you'll lose pressure. So on the pilot ignition, on the manifold, there'll be another pipe going to those pilots, and there's a little screw. It's an adjustment screw. Like when you go from LP to natural and natural to LP, you can adjust the size of the pilot because you're different gases. You need to shut that valve off with the screw. You tighten the screw down
You gotta close it.
so that the pilot is not leaking gas out. So if you want to test if this appliance is leaking gas or not. If it's a gas pilot oven, remember I said some are electric like this, but some of them are a gas valve. It has two lines going down to the oven. One line is for the main burner, the other line is for the pilot. There is a screw. The screw says natural, LP, or in the middle it says off. So you turn that pilot off and you turn the pilot off on the top of the stove to make sure none of them are leaking gas out when you're doing this test. I call it a drop test. You want to see if the pressure drops or not. But if a customer is insistent that their appliance is leaking gas, and you show, man, look, this is my reading,
It's actually going down.
11.87, and I turn the gas off, if it was leaking, I would see a drop. The water manometer will do the same thing. This one's not working right. It may have some dirt or something in it. We're going to clean them out and we'll
It's
test
dropping.
with it.
I think he got that valve open.
It's dropping a little bit because our hose is, we got electrical tape connecting the two hoses. They're not perfect. We have to have a better hose system connected to check it properly. But if it starts dropping, then you're right, ma'am, there is a leak. But if you go to a customer's house and you just put soap on everything and you don't see no bubbles, you say, man, the unit's not leaking. 9 out of 10 times customers, no, I smell gas. And there's nothing you can do to convince them. This is what you can do to convince them. And when you do that, you need to tell them before you make the test, ma'am, I'm going to go ahead and connect a meter to check the pressure on your stove. And then what I'm going to do is I'm going to shut off the gas coming in. If the numbers stay the same, your appliance is not leaking. Okay? That's something you have to tell the customer before you do it. Then when you do it, the customer can see and they can't argue with you. So I turn the gas off there. If I turn on this burner again, what's happening to my
Gone.
pressure?
Drop.
It dropped because I opened up another valve and I let all that gas out. Okay? That's what would happen if you had a leak. Maybe not that fast, but it'll drop.
It'll
Now there's
drop.
no more gas in the system. Maybe just a little residual, but there's no more gas in the system. I can't light it. I have to turn the gas back on. And then the burner lights. Okay? So that's the surface part of it. You got spark ignitions. You got the gas valve. It's just a valve, open, close. You manually turn it just like I did this tank.
Yeah.
Okay? We have the spark igniter. This is the piece that the spark comes off. You can see it sparking. If you look closely, you'll see a little blue spark coming off of there. What happens if one of these spark but the other one doesn't?
That means the
Could be
Most
switch.
likely my electrode is bad.
Electro bad. Or
Electro.
Okay, but if I turn them all on
Mhm.
and this one's always sparking, this one's not, is it my switch?
It could be.
No, because we said that no matter which one I turn on, they both spark. Always.
Mhm.
They both spark. So if I turn on all of them, and this one on this side is not sparking, but this one on this side is sparking, then maybe my electrode's bad or my module's bad. So how do I prove whether it's the module or the electrode? Swap them. Unplug the two from the module and switch them. If this one starts working when I move it,
Then
the
you know
electrode's
automatically
good.
The electrode's good and the module's bad.
The module's bad. If I switch it and this one still don't work, but this one works, then the electrode's bad.
Same concept for a car. So if you want to test a spark plug, you move it from a different cylinder and see if you have the misfire in the same cylinder.
There you go. So it's not very difficult. So today I just wanted to cover over the top of the stove, show you the gas distribution system. Tomorrow at 6 o'clock we'll go over the oven safety valve and how it works and how to test the oven safety valve voltage and amperage, and we'll see how it works, and we'll light it up, and we'll also do the adjustment on the flame. We're going to see what it looks like if it's set for natural. We'll see what it looks like for LP. Any questions on the stuff on the top of the stove? Yes, sir.
When you take out the orifices, right? Some people, I see people drilling it out, like to take it out. If it's hard to take out, you could drill it out, or
On residential units,
No.
they're not that hard. They have special orifice drills on commercial units where the orifice has something called a spud, and you could drill out the hole, put the spud in there, and you can make that hole any size you want. But these look like drill bits that fit on a magnetic screwdriver, but you don't use power tools. You turn it by hand.
so if you use power tools, what happens?
You destroy it.
It won't make a nice hole.
You probably destroy it.
Yeah, you know, it'll go so fast. It's that nice straight hole. It's going to go angle.
Yeah.
It's going to rip the hole, make it even bigger than it should be. So the hole size determines how much gas flows to that burner and how big that burner is going to be. But that's usually in commercial. Like if a customer bought a used stove,
Yeah.
it was set for LP, but they have natural gas. Well, you have to make the hole smaller. You can't make the hole smaller. They're not adjustable. So you drill out the hole big enough to put a spud in there, and then you hand drill the spud depending on the BTU rating. It tells you if you have this many BTU burner, this is the size hole you need on your orifice, and you drill it out. Okay, any other questions on the top of the stove and the components of the stove? Okay, so tomorrow we'll do the oven circuit. We'll tear the oven apart. And then later we'll go into this manometer, see if I can get this manometer working. I don't know why it's doing what it's doing, but I'll figure it out. All right, Carl, just